Okay, so we're gonna start a new chapter, chapter 4, oligopoly competition. So like always, we're gonna start with the goal of this chapter. The goal of this chapter is two things. One, to understand the Cournoid knot competition, right? So Cournoid competition and learn how to solve symmetric Cournoid duopoly problems. So here we have all the hint about how this game is systemized, right? We have a symmetric, so what we're looking is identical, right, players. And it's in the rule of Cournot, and we have how many duopoly? So we have two players in the market, right? So we're going to look at the duopoly identical player situation. And number two, we're going to understand the veteran competition and learn how to solve both symmetric and asymmetric Bertrand problem. So we have one Cournoid and two Bertrand, and in the Cournoid we're going to look only at the symmetric identical players, and in the Bertrand we're looking at both symmetric and asymmetric problem. Okay, let's start with Cournot model. So motivating example. Suppose there are two or production firm, so we're going to call that firm 1, and what is about the description is about the ExxonMobil, and we have firm 2, and the description about the firm 2 is a Shell. So we have two or companies and they are competing with each other in the market, right? So we're saying duopoly over here. We have two players, right? And the market demand is given by P equals to 100 minus Q. And that Q is composed of, what does that mean, right? So when we have the market demand, right? We're looking for 100 minus Q. So we have the demand curve P equals 100 minus Q. So we have to understand what is this P and what is this Q. In the Cournot, right, in the Cournot model, we have the same price because we have the same production model, but we can control quantity. Okay. So let's look. So we're looking for the quantity difference. So P will be same for firm 1 and firm 2, and that P, right? So this P is the price for the firm 1, price for the firm 2, and we just make it generalize in a P. What about Q, right? So for Q, we want to control, right? So we have different Q for firm 1 and firm 2. Firm 1 and 2 can decide how many units they want to produce, right? So it's not same, but we have to sum, right? So production of the firm 1 plus production of the firm 2 becomes the total quantity, right? So substituting Q with the little Q1 and 2, so it's less. Write it as little q1 plus little q2 equals to BQ, okay? So let's keep this way, and we're going to plug that into our demand curve of P equals to 100 minus Q. So what happened is P equals to 100 minus what? Q1 plus Q2, right? So that's why we have the demand curve that is equal to 100 minus Q1 minus Q2 in the slide note. So let's go back to the slide note. So we're talking about why we have the production function, and then it was going to Q1 minus Q1 and minus Q2 because Q, the BQ, the total quantity produced equal to what? quantity produced by farm 1 and quantity produced by farm 2 because we only have two companies, Exxon and Shell, in the market. Okay, so we further assume that they have identical production technology and labor costs, so their marginal costs are the same. So we don't have to calculate it. It's already given as a MC1, right? The marginal cost of farm 1 equals to the marginal cost of farm 2, and they have to spend $10 per unit production. Okay, and we're gonna ignore the fixed cost here. And moving on, the two farms here are strategically linked. For instance, take a look at the ExxonMobil's profit. The profit of farm 1 or ExxonMobil equals to the P minus MC1 times Q1. This profit is not only decided by the ExxonMobil itself, but also influenced by its rival Shell's production, Q2, right? We're not considering the differentiating in the price, but we're looking at the Q, the quantity difference, right? The production difference. And and because the market price P is jointly decided by Q1 and Q2, we have to apply our knowledge in the game theory to solve the problem. Take this market competition as a game, and the basic element for these games are: 1, who are the players? From 1, Exxon, and from 2, Shell. And 2, what are the strategies? They can decide how many they want to produce, right? Depending on the choice of Q2, and Q2 choose their quantity depending on the size of Q1, right? And what are the rules? They are using the simultaneous game, so they cannot know the other's decision, right? When we decide Q2, we cannot know what Q1 is. We cannot know it. We're blind, right? But theoretically, we can expect what the what other player's strategy is, right? That's how we solve the game. And for payoff, each player's profit function is their payoffs. So let's look at it. Okay. So go back to whiteboard. So what are the payoff? The profit, right? Profit is payoff. So how can we calculate the profit of a firm? Profit equals to what? Total revenue negative total expense. And total revenue is described by price times quantity, right? And the total expense is unit cost, the margin cost, times the quantity, right? So we can sum it up, we can factor out with price negative cost times Q becomes the profit. So when we have two forms, how can we do it? We can divide by the farm, right? Farm 1, the ExxonMobil's profit, depending on what? The price is what? Set. We have the same price. What about the cost? We have the same cost, right? What about the quantity? We have different quantity for different company, right? So the profit for ExxonMobil will be what? Price negative cost times Q1. And for the payoff of Farm 2, Shell is equal to P negative C times Q2, right? And we know that Q1 plus Q2 equals to big Q, so we can substitute Q1 with total Q minus Q2, or Q2 with Q minus Q1. So what we're saying is Q1 depending on Q2 and Q2 depends on Q1, right? They are interactive, right? So going back to our slide. let's see what we want to solve. Using this model, we want to solve one Nash equilibrium and two market equilibrium price P star, that P we're looking for, and each firm's profit. We want to know profit 1 and profit 2. And 4, we want to know the consumer surplus CS, and we can move on to social welfare also as number 5, right? Okay, so how can we find the Nash equilibrium? To answer it, we have to look at the best response function. So given Firm 2 strategy, Q2, Firm 1's marginal cost function is given by this. It says this. Oh, what is this? So we're going back, right? The marginal cost. So we're going to have a look at the total cost. So what is marginal cost? And this is marginal revenue. Oh, do we have to look at the marginal? Yeah, we have to look at the marginal revenue and the marginal cost. So we have to look at the marginal revenue. What is marginal revenue? It's the derivative of a total revenue with respect to quantity, right? So how can we get this in marginal revenue of Firm 1, right? So what we have to do is substitute everything into Q1. So let's look, what was the total revenue for Firm 1? It's price times quantity, right? And in this case, we have to put what? It becomes price times Q1, right? And in the demand curve, we had the P equals to 100 negative BQ, and that was 100 negative Q1 minus Q2, right? So we're going to substitute this P with 100 minus Q1 and Q2 and get what? We have 100 negative Q1 minus Q2 times Q1 as the total revenue for the Firm 1. So what we have is 100 times Q1 negative Q1 to the power of 2 negative Q2 times Q1. So let's take a derivative of Q1 to get the marginal revenue of Firm 1. So what is marginal revenue of Firm 1 is the total partial derivative of total revenue from, it's 1, not 2, it's 1. Revenue 1, right, for Q1. So what we have is power goes down, so 100 times 1 times Q1 to the power of 1, negative 1. So we got the power of 0, so it's only 100. Negative, what? 1 times the power goes down, so 2 times Q1 to the power of 2 minus 1, so 1. Negative, right? We have Q2 as coefficient, and the power of 1 goes down, so stay the same, and Q1 to the power of 1 minus 1, so it's 1, and so we have the marginal revenue of Firm 1 equals to, marginal revenue of Firm 1 equals to 100 minus 2 Q1, right, negative Q2, right? The marginal revenue of Firm 1 is not only decided by the quantity of itself, but the quantity of the competitor. Okay, so what can we do next? So since we're thinking about their selfishness, right? So they're acting like a monopolist, right? So they want to set that their marginal revenue equals to marginal cost. And we had the same marginal cost for Firm 1 and Firm 2 as 10, right? So what we see is now, what? 100 minus 2Q1 minus Q2 equals to 10, And thus, if we solve for it, we find Q1 equals to 45 negative 0.5 times Q2. And since we have the symmetric production of form 1 and form 2, what will be the quantity for form 2? It's same, 45 negative 0.5. Now it's times Q1, right? So we have Q1 and Q2 in the equation of each other. So what can we do? We can plug one into the other and solve the equilibrium. So let's clean it and write down. So what we had was Q1 equals to 45 negative 0.5 times Q2, and Q2 equals to 45 negative 0.5 times Q1. Okay, so we're going to plug Q2 into the Q2 and solve for Q1. So Q1 equals to 45 negative 0.5 times 45 negative 0.5 times Q1. So we have 45 negative 0.5 times 45 plus 0.5 times 0.5 times Q1 equals to Q1. So what do we have? 0.5 times 45, so we have 22.25, right? 22.5. 22.5 plus 0. Let me see. 0.25 Q1 equals to Q1. So we have 0.75 Q1 equals to 22.5, and thus we get the quantity of 1 equals to, okay, so we have 22.5 over 0.75, we get 30. The quantity of 1 equals to 30. What about Q2? Now all we have to do is plug 30 in the Q2 solution, right? So now we're going to use this and now substitute this with 30. So what do we have? Q2 equals to 45 negative 0.5 times 30, right? And thus we have 45 negative 15 equals to 30. So after all, we got the same size of the production for Exxon and Shell, right? Since why this is happening is because they have the same production construction, their marginal cost is same, right? Marginal revenue should be same, and it's easier for just splitting the market with the same quantity because they cannot control the price. Let's go back to the last note. So to solve the Nash equilibrium, we got what? 30 and 30 for both Exxon and Shell. So another way to solve it goes as follows. Because these two forms are totally identical, they have the same cost structure, their respective production decision have the same impact on the market price. Therefore, our optimal decision should be also identical. That is, Q1 equals to Q2 equals to Q, right? So we're substituting every Q is same values, just like the price of 1 equals to price 2 equals to P. We have the quantity 1, quantity 2 should be same as the quantity, right? Because we are sharing the same size, right? So in this case, in this particular case, then what is the market demand or market quantity is what? 2 times Q will be the total Q in this case. Okay, so let's move on. So when we have this solution, we can put what? Instead of Q1 and Q2, we put Q and Q, and we get the Q equals to 30. Simple solution when we're having the same cost structure. Right? And number 3, to solve the market equilibrium price, what can we do? So we're going back to the demand curve. What was demand curve? P equals to 100 negative big Q, or 100 negative Q1 plus Q2. So what was the quantity for form 1? We had 30 and we had 30, right? So the P equals to 100 negative 60, the total quantity Q. And we get the price of $40, right? And number 4, what is each firm's profit? So going back. So profit, once again, how can we calculate the profit? Profit equals to what? P minus C times Q. And for a specific firm, we have pi 1 equals to P1 negative C1 times Q1, right? But in this case, we have the same price P and same margin cost C and same quantity Q. So we can just use the same structure. So what is, so we can say that for pi 1, pi 2, we have the same value as P minus C times Q. Okay, so what is the price? We just calculated, that was $40. What about the cost? We have the marginal cost at $10, right? And what about the production size? Each farm, right, produces 30, right? So we have 30 times 30 equals to 900 of a profit for each farm, right? So profit for farm 1 equals to 900, and profit for farm 2 equals to 900. When we look at the market cap, right, combined, pi 1 plus pi 2 is what? 108,000 if we look at the total society. And let's get the last one. And we want to solve the consumer surplus, and we can sum up all the consumer surplus and the firm's profits into social welfare, right? So we got profit of a firm 1 equals to profit of a firm 2 was 900, so total profit was 2 times 900 and 1800. And for social welfare, we have to have pi plus consumer surplus, right? So we got the pi, but we don't know the consumer surplus, so let's look at it. So how can we decide consumer surplus? Once again, when we have the price and quantity, right, it follows the demand curve, right? And the demand curve has the equation of P equals to 100 minus Q. So we're starting at 100 and decrease by the number of Q, and at a Q of 60, right, the double the size, right, Q1 plus Q2 equals to PQ. At here we have the price of 40, right? That is the P star or P1 equals to P2, right? For all of the prices, we have the same price as 40, right? So where is the consumer surplus? It's over here, right? Those are the people who are willing to pay for this money, right? And only the price is right here. So the first consumer is benefited about that much, right? For the $60 value, he'll be happy, right? For the next one, 59, $0.999 happier, and until $0 happy, right? So the area size is the consumer surplus. What about the profit? Right, we have the cost right here at $10, and the whole size is what? Total pie. Well, we can split it into 30 and 30. So we can have it as pi 1 plus pi 2, and together becomes pi. Okay? All right. So let's calculate the consumer surplus. So how can we get the consumer surplus? It's a triangle, right? Starting at 0 to 60 right there, and we have what? 40 to 100, right? So what we're doing is trying to capture the gap. The length is 60, the length is 60, right? So how can we get the dimension of the triangle? We have what? 60 times 60, right? The length of each side times half. So consumer surplus equals to what? 3600 times 1 over 2, and we have 1800. So we got 18000 for consumer surplus and 18000 for firm's profit. So after all, we get the social welfare equals to 1800 plus 1800, that is 3600. Okay. All right, let's move on to part 2, Bertrand model. So more devising example. Suppose there are two Chinese restaurants, F1 and F2, competing with each other in the market. The market demand is given by P equals 100 minus Q, where Q is the market production. We further assume that they have identical production technology and labor costs, so their marginal costs are same. MC1 equals to MC2 equals to 20. Sorry. To simplify our analysis, we ignore the fixed costs here. Different from the Cournot model, here the two firms compete directly in terms of prices. Before, we're fighting for what? We were fighting for quantity, right? And now we're fighting for price. That's the differences, and they produce identical products. The firms charging the lower price wins the whole market, right? So it's all have or nothing market. If you have the same price, right? If you and your competitor charges the same price, you can have a duopoly, right? If your price is lower than your competitor, then you can have it as monopoly, right? And if your price is higher than your competitor, then you will have nothing, right? This is the model because the product is identical. Okay, so here we want to solve Nash equilibrium of P1 star and P2 star, and 2 market equilibrium production level Q1 and Q2, and 3 each firm's profit, and 4 consumer surplus. Okay, before moving on, we want to look at the difference between Cournot and Bertrand. First, in Cournot model of firm strategy is about production, it's about the quantity, right? Where the Bertrand model firm engaging in the direct price competition, right? So in the Cournot model, we set the price as just P, right? Because we have the same P for P1 and P2, right? After all, we got the same Q1 and Q2 in the what? Identical firms, but we will not have the same production if we don't have the same what? Cost structure, right? And here we're setting what? Q1 and Q2 as what? Not generally Q, but it's what? Either the whole Q, or you get half of Q, or you get 0Q, right? So it's all, half, or nothing. So it's not firm specific, right? We don't have to name it right Q1 or Q2 because it will be what, the whole, half, or zero portion, right? Okay, so moreover, birch fund competition is actually much more severe than Cournot competition. Take a look at the firm's best response function in the Cournot model. We find a firm only slightly modify its strategy when its rival changes its strategy a little. But in a birch fund model, a slight change in price, right? That can make a huge difference. What difference? You can take the whole market or you end up getting nothing, right? So this decision is a critical decision in the Bertrand model compared to Cournot. So for instance, suppose the two firms initially both charge $80 and share the market equally, right? If either one of them slightly lower the price to $79.99, then it will win the whole market and its rival will be total loser, right? Here the Bertrand small change in strategy will cause a dramatic change in the outcome, and so the competition here is more severe. So below we solve the Bertrand model. Let's look at it. So to answer, we have to find the response functions. So note now we cannot apply the same method as we use in the Cournot model because we have the different situation, right? So we have the situation, we have the scenario. The bottom scenario is in the Bertrand model, the bottom of any firm profit should be 0 because it can always charge the marginal cost MC and its price to make sure they earn 0 profit. And we have the top case, right? In the all possible case of a firm, we can have 0, half, or, right? So when the firm monopolizes the market, choosing the monopoly's price of, let's say, monopoly, and earning the monopoly's profit of monopoly is the best he could do. So the monopoly's profit pi m is the top of his profit, and in this example, MR equals to 100 minus 2Q. So going back again, we have the total revenue equals to P times Q, right? And we have the P equals to 100 minus Q, and in the best case, what is happening? He is getting the whole Q, right? So if we take the partial derivative of respect to the total market Q, we get 100 negative 2Q, right? And we want to set that equals to marginal cost, and the marginal cost was, let me see, $20 was $20, right? So we're setting 100 minus 2Q equals to 20, and 2Q equals to 80 with Q equals to 40. So when he's monopolizing the market, he will only produce how many? 40 products, right? And he will charge the what? P right there, right? So P is, okay, so we got Q equals to 40, and what is P? P is 100 negative Q, right? So we have 100 negative 40 equals to 60. So when a firm is monopolizing the market, the Q of monopoly will be 40, and the P of monopoly will be 60. Okay? And what about the profit? Profit will be P negative C times Q. So we have what? 60 negative 20 times Q of 40 of $16,000 profit if monopolizing. So this is the best case scenario profit. The top case profit equals to 16 with P equals to 60, Q equals to 40. And bottom case, we have the profit of 0. And if we sell it, we have to have the price at our marginal cost, right? So 20. And the Q, I don't know. Because we're getting nothing, so it's better to produce nothing. Okay, so let's look at the functions. So if price of the farm 2, right? So I'm gonna rewrite it. If P2 is smaller or equal to the marginal cost of farm 1, that is 20, right? If the price 2 is same or smaller than 20, then what is the P of 1? So what he's charging is P2 is charging smaller or equal to 20, and 20 is what? That is marginal cost. So can P1 be lower than 20? No, it is the marginal cost of the firm 1, right? So he has to charge $20 because if he charges like $20 and even like 10 cents, right? Who will win the game? P2 will win the game for sure. So he has to go for the lowest price possible, which is his marginal cost, right? And we know that P2 cannot charge like lower than 20 because we have the same marginal cost for 2 is also same as 20. So P1, P2 will charge the same price of 20, right? And number 2, if P2 is greater than P1 of what? Monopoly, right? If P2 is greater than the monopoly price of farm 1, right? And that value is 60. If P2 is greater than 60, right? Not greater or like not equal or greater, but if it's greater than 60, what is happening to P1, right? So if P1 monopolies the market, he would charge what? $60, right? He doesn't want more than that, right? So if P2 is charging more than $60, he can charge $60 to get the max profit of $16,000, right? So when P2 is greater than 60, the best solution for P1 will be 60, right? And number 3, if MC1, right? MC1 is 20 and we have P2 in between this. So if P2 is between, right, 20 and 60, right, we can have the low end, high end. What about in the middle? What happens if P2 is not in the neither extreme side? Then the rational choice is to charge P1 should be a little less than P2, right? So this represents like small amount of price, right? So P2 can be what? We just want that P2 be slightly bigger than P1. Then P1, right? The farm 1 will win the game at no matter what the price of P2 is, right? If it's $60, right? Then P1 goes to 59.99, right? That wins the market. So if the price is in between, it's easier if we know the competitor's price. But what happens in the reality? What was the rule of the game? Can we know the decision of the other person? We cannot. We're doing the simultaneous game, right? One cannot know the other's decision when he decides his choice, right? So this cannot happen, right? So what about this? If P2 is greater than 60, what is the maximum price for P2, right? What is P2 M. We have the same cost construction for P1 and Farm 1 and Farm 2. So if Farm 2 monopolize the market, the price will be same as 60, right? So there is no way P2 is going to be greater than 60, right? So the only choice is charging the lowest price of $20 for each farm, right? Because of what? Because we can lose, right? We can, this is not happening, and this we can lose, right? So the safest option is to get nothing but not losing. Okay. So following the same logic, we can write Form 2's best response function as follows. Same thing, if P2 is at the marginal cost of Form 2 or lower than P2, if P1 is same or lower than the marginal cost of Form 2, then P2 should be the marginal cost, right? And if P1 is greater than the monopoly price of Form 2, then Form 2 chooses the monopoly price. If the marginal cost of Form 2 is smaller than P1 and it is smaller than 60, right? The monopoly price of the Form 2, then P2 can choose a what? A slightly lower price than P1. But this ain't happening, right? So we have 1, 2, 3 options for each farm, but the only double checked is to charge the same price at marginal cost. Okay. But let's see. So here we have the P1, P2 equals to 20. So what is the Q? In this case, Q equals to 100 minus P. Where does this came from? This is from our demand function of P equals to 100 minus Q. Now we're reversing it, right? So Q equals to 100 minus P. So since we got the P of 20, right, we got the Q was 80, right? And what is this Q? Again, this is what? Q1 plus Q2, that is 80. So for each farm, Q1 and Q2, they each get 40 and 40, right? So first question, we got the price for each farm. And second, we got the quantity for each farm. So we have to have what? Profit and consumer surplus. Let's go back to the whiteboard. Okay, so we have P equals to 20, right? And Q equals to 80, and that is what? 2 times Q1, where Q1 equals to Q2, right? So each farm produces 40s. So what is the profit for farm 1? That is P negative C times Q1. And what is P? We have equivalent price at 20 with the cost 20, and the quantity produced is 40. So what we get for the profit of farm 1? $0, right? Price equals the cost. What about the farm 2? We have the same situation, P minus C times Q2. What is P? 20, C 20, Q2 40. So like farm 1, we get the 0 profit for farm 2. So for the profit, we have 0, right? 0 plus 0 became 0. What about consumer surplus? Consumer surplus. So again, we're gonna draw P and Q 100, and what we're got is 20, got 40, right? And this is the part where we have the consumer surplus. For the profit part, right, we have 0 because the price equals to cost, right? So what is the consumer surplus? We are now detaching the triangle. We have 100 right there, 20, 0, 40. So we have the length of 80 and 40. The dimension is half of 80 times 40. We get 32, right? So 1,600 consumer surplus. Well, what the social welfare is a profit of the firm aggregate plus consumer surplus. So aggregate profit was 0 and we have the consumer surplus of 1,600. So the total social welfare will be 1,600. Okay, let's go back for the last part. Hmm? 1 second. I was drawing a triangle and there was 120, we have 0. I thought was that. Okay. Alright. More time. I was wrong. Okay. I was a little confused with that. Okay, P equals to 20, right? And Q equals to 80, that was 2 times Q1, right? That was correct, right? We have the pi 1 equals to what? P minus C times Q1, that was 0, and pi 2 was P minus C times Q2, right? Q1 equals to Q2, so that's 0, that's correct. What about the consumer surplus? I was wrong by the, what? 100 minus P part. P, Q, we have 100 minus P, that's correct. But I was wrong about, I was just taking what half size of 40 into the quantity, and that made me wrong choice. Okay, the aggregate quantity is 80, not 40, right? And we have the price equals to cost at $20. So if we're detaching the triangle, right, we have 80 right there, and also 80 on the horizontal. So the dimension is half, thus 80 times 80, and we got 6,400 by half, and we have 3,200 of consumer surplus. Right, that's consumer surplus. And the social welfare equals to 0 plus 3,200 equals 3,200, right? So I was wrong about, like, I have to have double the size of each quantity, or I have to look at the whole quantity, but I was just taking the part of it and then forget about it. So don't make a mistake like this. So the total quantity is aggregate, right? And when we're drawing the what? Demand curve, this is about what? Aggregate, right? Q1 plus Q2, not Q1 itself.